looking for some new activewear clothes. I signed up for a recreation class this week and I don't really have anything to wear.
Oh, which clothes are you looking?
I'm looking for something that'll be somewhat reliable and will last me a while and hopefully dries relatively quickly in case they get absorb any moisture or get wet.
Oh, fair enough. That's definitely important if you're working out in them. Do you want to help looking?
Yes, please.
Oh, this one is good. It says that it's meant to last during workout classes.
Oh, it does look interesting. I wonder what makes it so special.
Let's find it out.
Hey, have you heard of nylon? It's what everyone's been wearing nowadays, especially your favorite athletes. Nylon is the perfect balance of durable, soft to the touch, and snag resistant. It's even moisture wicking, it's breathable, and it stays in place. So elevate your workout now and shop the new collection. So what are you waiting for? Just add it to your cart. What is the history behind Nylon 66? Chemists in DuPont Laboratories wanted to create a fiber that could compete with silk. The first nylon, which is nylon 66, was synthesized in 1935 by Wallace Hume Carruthers at DuPont's research facility. They discovered that by mixing adipic acid and hexamethylene diamine and removing water, they could synthesize a polymer called nylon 66. Nylon 66 was the world's first fiber to be made in lab. The 66 in the name comes from the two carbon molecules used during synthesis. The first commercial use for nylon was actually a nylon bristled toothbrush, and following that became famously used in women's stockings. Extensive commercial applications of nylon include use in automotive parts, apparel, and packaging. Unlike natural fibers like cotton or wool, nylon structure is entirely man-made through a process called polymerization. Nylon is a polymer, a long chain of carbon-based molecules called monomers. While there are different types of nylon, most are derived from polyamide monomers that are extracted from crude oil, which is also known as petroleum. Specifically, a monomer called hexamethylene diamine, also called diamine acid, is extracted from crude oil and reacted with adipic acid to form PA66. This was the first type of polymer to be used for nylon fabric and is in the form of a crystallized salt. The salt is heated to form a molten substance and then shaped by running it through a spinneret, which is a device that has dozens of tiny holes. When extruded through the spinneret, nylon immediately hardens in the form of a thin fiber that is ready to be wound around bobbins. The fibers are then stretched to improve strength and elasticity and colored before it is then again wound around another spool in a process known as drawing. Now that we've talked about the synthesis of nylon, it's also important to talk about the impacts on the environment. The production of nylon fabric generally has a negative effect on the atmosphere due to the raw materials used in its production. While it is possible to synthesize nylon fabric using other materials, most companies use crude oil as their main source of hexamethylene diamine because it is an abundant and cost-effective source. Much of the oil industry's profit comes from producing gasoline. The other fractions used for plastics are often considered byproducts of that process, making it cheap to acquire. Petroleum-based synthesis also produces a very strong, lightweight, elastic fiber that is highly resistant to abrasion. In addition, large amounts of water is used to cool nylon fabric fibers, which often as a result of this process carries pollutants into the hydrosphere surrounding manufacturing locations. The production of adipic acid also releases nitrous oxide into the atmosphere, which is projected to be 300 times worse for the environment than carbon dioxide. Now let's take a deeper look into the polymerization. The polymerization begins when two adipic acid molecules interact. One adipic acid molecule protonates the carbonyl oxygen of another adipic acid molecule. When this oxygen is protonated, the carbonyl oxygen becomes more vulnerable to attack by the nitrogen in the hexamethylene diamine. As it pulls on the electrons it shares with the carbonyl towards itself, leaving the carbonyl carbon lacking electrons, but ready for the amine nitrogen to donate a pair to it. This creates an ammonium intermediate. The electrons from the hydrogen-oxygen bond go back to the oxygen, freeing the proton, which regenerates the acid catalyst. Then the carbonyl oxygen shares its newly regained electrons with the carbon atoms, regenerating the carbonyl double bond. The oxygen of the hydroxyl group then steals a hydrogen from the nitrogen, forming an amide dimer as water breaks off. The dimer can then react with another molecule of the adipic acid or hexamethylene diamine to form a trimer.
and then react again with bigger oligomers until they become big enough to be called polymers. Eventually, after multiple reactions with bigger oligomers, we finally produce nylon 6,6.
You might be wondering, why nylon? Why can't we go for polyester or cotton instead? Well, although polyester is lower in cost than nylon, nylon is a lot stronger, it's more elastic, and it's softer. Plus, cotton absorbs a lot of water and it stays heavy, while nylon wicks sweat away from the body. So if you're working out, I don't think you'd want to be drowning in your own sweat. So that's what makes nylon perfect for activewear.
That was definitely helpful. Do you know which one you should check out?
Yeah, I think I'm definitely gonna get this one. I'll order it now. It finally arrived.
Let's open it up.